Okay, induction proof now. So one, we're required to prove case n equals 1. So does 1 squared equal 1 times 1 plus 1 times 2 plus 1 over 6? Well, that's 1 equal to 6 over 6, so that's true. 2, we assume case n equals k is true. That is 1 squared plus 2 squared up to k squared equals k plus 1 times 2k plus 1 over 6 is true. 3, we're required to prove case n equals k plus 1 is true, i.e. 1 squared plus 2 squared up to k squared plus k plus 1 squared. That should equal k plus 1 times k plus 2 times 2k plus 3 over 6. I'm putting k plus 1 instead of k. So the way we do that is by substituting. That is, sub in 2 here for that. So we end up with k plus 1, 2k plus 1 over 6 plus k plus 1 squared. I need to show that that's equal to k plus 1, k plus 2, 2k plus 3 all over 6. I'll multiply here by 6, so I can cancel all these 6's here. I can cancel a k plus 1 from everything. So I'm left with k times 2k plus 1 plus 6 times k plus 1. Does that equal k plus 2 times 2k plus 3? That's 2k squared plus k plus 6k plus 6 equals 2k squared plus 7k plus 6. That's 2k squared plus 7k plus 6 equals 2k squared plus 7k plus 6. Perfect. So now our logic 1 plus 2 plus 3 means it's true for case n equals 1, then its neighbor, then its neighbor, then its neighbor, etc. So yeah, pretty standard question.